In 2.1, we are going to talk about relations and functions and what makes a relation a function. If you remember, a relation is any set of ordered pairs. You must know this from Algebra 1, that this is the x-axis, here is the y-axis, here is the origin, which is 0, 0. And then you have quadrant 1, 2, 3, and 4. To be able to put these points on a graph, or Cartesian plane is what it's called, or a coordinate plane, you must know where they are positive and negative. So my x is positive here and my y is positive here. Remember, it's always alphabetical. X comes first, y comes second. My x is negative, my y is positive. My x is negative, my y is negative. And my x is positive and my y is negative. So if I need to put 2, 4, this is example 1, and it's A on this plane, I'm going to go to the right 2 and up 4, and that is point A. B is 3, negative 2. So I'm going to go to the right 3 where my x is positive and down 2 because my y is negative. C is negative 1, 0. So I'm going to go left 1 where my x is negative, and I'm not going to move anywhere for my y. And then D is negative 3, negative 4. So go left 3 and down 4 for D. That is just how to graph on the coordinate plane. Remember, any set of ordered pairs is a relation. And there's lots of different ways to list a relation. You can do it in a table like this. You can do it in the graph like here, and you can do it like this: 1, 3, 5, 1, 2, that's negative 1, 2, 3, 4, and then I would draw, if I'm using these ordered pairs, I would do this. And then I also can do it in a set like this. Either one of these is acceptable, except this one right here is not the same ordered pairs as these 3 down here. I was just using that as an example. That is all at the top of page 57. To make it a function, none of your x's can repeat. So since there are 2 arrows coming off of 3 here, that means it would be 3, negative 1, 3, 2, just like here, and my x's repeat. Those are also called the domains, and the y's are the range. So my domain can never repeat. So in example 2, there they give you this, and they say, and notice the arrows only point to y. It's never pointing to x. So they ask you to represent that relation in a set of ordered pairs, which would be like this. They ask you to do it in a table, which would be like this. And then they ask you to do it in a graph. And I'm not going to graph that out, but that is on page 57 in example 2. Then they ask you what the domain is. Remember, your domain are all your x values, and your range are all your y values. When you have a graph that looks like this, and 1, 2, 3, and it asks you to give the domain and range. This is an example 3. This is B. A you can do, domains are your x values, and y is your range. But when you have a graph like this, you have to give all of these numbers from this open point to this close point. An open point on the graph means all the numbers up until that point is graphed. So if we would not have -1, -3 in our domain and range, but all the numbers up until. So if we're looking at our domain, we would have to do this. We open this. This means x, because domain's x, such that, okay, so you have to do it like that. When we're talking about domains, we go x such that, which is this little line right here. And we're talking about x, so we're going to bring up x over here. We're going to have this. But if we look, our least x is -1. But it's really not. It can be every number up until -1. So we do not have an equal sign right there. It's just a greater than sign because we're reading it from x. So every number between -1 and 2, because this is 2, 3, okay? And it has to be equal to 2 because it's a filled in dot. And then we close that out. So our range is going to be y such that we're going to skip over here and make a little y. And we'll fill in whether it's equal to or not. But we're going to put our least y, which is -3, which is right here. And it can't equal, so it's not going to be equal to, it's just going to be greater than. And then 3 is our greatest y, and it can equal 3. And then don't forget to close that out. So if you're looking, or I'll do it. The next part, the C part, and I'm going to do this as good as I can, okay? So we need to find our range and our domain. We'll do domain first. Domain equals, it is every number that x is. Remember, domain is an x. So my x's start here, and they go forever this way. So it starts at 0, and it goes forever. There's not going to be a least and a greatest. There's only going to be a least. So x is greater than or equal to 0 because there's no open. It actually hits 0. And that's my answer on the domain. My range is y such that, and if I look, and we may change this up in just a minute, these arrows, not only is it going to the right forever, it's going up forever and down forever. So it's going to hit every y ever, and that's infinite, right? So instead of this part, it's going to hit every number, so it's all real numbers. So we talked about functions, and functions are where your x's never repeat. So this was not a function here because we had 3 2 times for my -1 and for my 2. So that is not a function. If you look at the top of page 58, to the right, there are 3 E, A, and F. E is a function. There is only one arrow coming off of each of those domains. A is not a function because there's 2 arrows coming off of 3. That means 3 goes with -1 and with 2. And F would be a function. Even though all 4 arrows are going with 4, I never said anything about Y not being able to repeat. Y can repeat as many times as it wants to. My X can never repeat for a function. So if you look at, and I'm not going to even write these out, example 4a, my domains, I'm only looking at my x's, 1, 2, and 3. X never repeats, so A is a function. If I'm looking at B, there are 2 arrows coming off of 8, so that means 8 would be there 2 times for my X. B is not a function. Look at C. We have something that resembles this. You do the vertical line test. Any of these lines, if it hits the function in more than one spot, so that line hits there, that line hits there, and it has to be vertical lines. So if any line hits that more than one spot, it is not a function because this X is here and here. This X is here and here. If I have this, though, every vertical line only hits that graph at one point. So D is a function. C is not a function. D is a function. In example 5, we are just evaluating. That simply means we're putting what we have in for X. So they have the domain as -2, 0, 4. I'm just putting those numbers in for X one at a time. If it gives us 3 numbers for the domain, we're going to have 3 answers. If it gives us 52 numbers for the domain, it's going to have 52 answers. So f of x means it's a function. It takes the place of y. No big deal. And it says, hey, wait, our domain is going to be this. By the way, this is a linear equation. If we graphed it, it's going to make a line. So I'm going to put -2 in for x. So that gives me -6, -5, which equals -11. Okay, and then I'm going to put 0 in for x. So 0 minus 5 equals -5. And I'm going to put 4 in for x. And those are it. So, I could answer like this and give my set. Or I could just have those as my answers. Now, that is a great way to be able to graph this. So, if it gives me this function, and g of x is just another way to say the function of x. They use g sometimes they use h, whatever, something of x. This does not mean g times x when that starts an equation. And they use different letters just to differentiate between. You may have 2 functions at the same time. So that means we're going to put these numbers in for x. So I could put every number in, or I can just put some of them. So you want to set your table up. You want to have your x to the left, your function in the middle, and your y to the right. So I know definitely I'm going to put my lowest and highest number. It can equal those because it has the equal signs. And then in here they put 0 and 2. It's fine. If you wanted just to put 1 there, it's okay. I know this is going to be a line because that's a linear function. So now I'm going to put those numbers in, and because we're taking half, that's why they used even numbers. It's just easier to graph whole numbers. So -1/2 times -2, that means you're just dividing -2 by -2, okay? And it gives you a +1. You can do this in your calculator. Don't get hung up on the mathematics. And so now I'm going to graph these. So I'm going to graph these points. -2, 1 is here. 0, 0. 2, -1, which is here. And 4, -2. And because it has this part, it doesn't want separate points. This is a continuous line, but it does have endpoints of -2 and 4.